Let's now apply our understanding of the normal distribution to work on this problem as an example. And at the start of this example, we are given SAT scores being our data. SAT scores in the year of 1997. And once again, notice that we have a plural here, but didn't indicate how many. So clearly this is a population data. So I am going to use a capital letter X as a random variable to represent an SAT score in 1997. And so clearly speaking, X here has to be a continuous random variable, and it's representing a population data. Continuing to read the description of the problem, we were instructed, it was indicated that SAT scores in that year 1997, this phrase here is saying the scores were normally distributed. So now indicating that our population data is normally distributed, is being distributed by a normal distribution. And then further, reading further into the problem, and by the way, this is so far only the description of the problem of the data. And so now we know that our population has a mean being 950. So I am now going to put it here. And having a standard deviation, a population standard deviation of being 150. So now this is a symbolic expression of our data. And at this point in our experience working with the normal distribution, then we are going to draw an empty bell curve. The horizontal axis here is to represent all values from low to high of the random variable X. And being normally distributed, our PDC has to be a nice looking bell curve. The specialty of the bell curve is the mean value 950 must be placed right at the middle of the bell curve. The standard deviation, population standard deviation, even though not clearly seen in a picture, but it's always a good habit to note it somewhere near the bell curve. From the data given to us with its description here, we now have the question asking us to find the probability where our random variable takes value below 600. So in my empty normal distribution, already prepare for the problem to work, 950, the mean value being right at the center. Population standard deviation is being noted here being 150. So 600 at start makes sense to be simply somewhere. And keep in mind that we do not need to be too precise about how far it is in terms of how many standard deviations. That's not what we need right now. All it needs here is that somewhere makes sense to be to the left-hand side of 950 because it's below mean. And now we're going to be more importantly making a shade that describes we're looking for the probability. So this shading area represents the probability where our variable takes value below, meaning to the left of 600. And remind yourself again that this horizontal axis is where all values of the random variable X are being arranged at. And so now apparently that we're not working on a standard normal distribution. Instead, we're now working with some general normal distribution where mean is no longer 0 and standard deviation is no longer 1. So learning from our earlier video lesson, then it is clear that we need to, our first step here is to find a z-score of 600. It is just my own habit that anytime I'm doing, because later on we will be working with many different value of the random variable. So we have to end up finding many different z-scores. So here I'm using a subscript 600 here to indicate that this is specifically the z-score of 600 that I am looking for. So here the math for finding z-score 600, the value that we're looking at minus 950 and divided by 150. Calculation comes out to be, and usually rounded to 2 decimals, minus 2.33. Once the z-score is calculated, what it means now is our probability on this normal distribution where the random variable takes value less than 600 will exactly be the probability that's on the standard normal distribution. We're looking at a z-score value below negative 2.33. Or thinking in terms of area, then this shaded area is exactly the same as the area on the standard normal distribution, where we're shading z-score below negative 2.33. And now to find this area, or to find this probability, the answer is just as directly as using some technology to calculate the designated area shaded to the left of z-score negative 2.33. I am going to be using my normal CDF command on the TI-8384 calculator. So to get started, again, on my home screen, I am going to press second variables, which brings up the distribution functions menu. Now I'm going to scroll down to option number 2 and click enter. So for our interval currently, it's an interval where we have no definite lower end. So that's why now on my normal CDF command menu, or as a command, we are going to enter the low end to be negative 1E99. So again, to recall how we get it done, negative 1E99. Then upper value in this case is our value for the z-score that we have found previously. So negative 2.33. And again, I am going to leave these two values defaulted to be 0 for mu and 1 for sigma. That means I am going to hit enter a few more times. And now TI-83 and early 84 calculators, instead of seeing manual as what you have seen earlier, you will be seeing a command directly printed on your screen as following. And so we go ahead and type it in as following: lower end, upper end, comma, 0, comma, 1. And now we are ready for executing the command. So now the area has been found. The area on the standard normal distribution bell curve shaded to the left hand side of negative 2.33 is calculated to be 0.009903053, and a lot longer. And that is exactly the same as the area on this general normal distribution bell curve with center at 950 and standard deviation 150. We are calculating the area shaded to the left of 600. So now the final answer in 4 decimal places. It's 0.0099. And as you have already seen, the answer was much longer, but unless being specified otherwise, usually I would go with 4 decimal places. Or in case the problem is asking you to put your final answer in as a percentage, then this is equivalent to a 0.99%. The same problem and data given to us, we are now asked to find the probability where our random variable x takes value above 1150. So on another empty prepared bell curve here with the mean at 950 and standard deviation 150, let's now lay down the shading that described our probability question. So we are looking for the probability where our random variable stays above And keep in mind, again, be aware that there could be time where we have equality signs in our inequality, but it's okay. It will not change the way how we do the problem at all. So here, once again, probability where our random variable takes value above 1150. So without the worry to be too precise on scale, all it needs to make sense here is that 1150 must be to the right hand side of the mean value somewhere. So I'm going to pick a value here. I'm going to say this is where 1150 is. All it makes sense here is that 1150 stays to the right hand side of the mean. And looking at value of x being above 1150 means we are going to produce a shaded area to the right hand side of 1150. And so this value of the random variable x is not on the standard normal distribution, and what we have here is only some general normal distribution. So the first step is to find the z-score. Z-score for this value being 1150, I am using a subscript to indicate that here we're finding the z-score specifically for 1150. The math for finding z-score, here it comes, 1150 minus the mean in the middle of the bell curve and divide by the standard deviation, 150. And that standard deviation was noted somewhere on our data, on our normal distribution curve. Calculation comes out to be 1.33, positive 1.33 in 2 decimals. And like I said again, that very commonly that in a lot of computations, a z-score of 2 decimals is usually required. But keep an eye on any other different requirements on how far to round for z-score before we proceed into finding the area. But once this z-score is calculated, once again, what it means is that this area we're shading here, representing the probability on our bell curve having the random variable x taking value above 1150, this probability is exact same value as the probability on our standard normal distribution, where z-score is above positive 1.33. And this mean value is equivalent to z-score 0, so 1150 is equivalent to z-score 1.33. So this shaded area would be the same if you would imagine that, if this curve here would be the standard normal distribution curve where all of these values are standardized into z-score, then this would be the same amount of area on that bell curve, the standard normal distribution. And so now to calculate the area as indicated, I am going to use the TI-83 or 84 calculator with the normal CDF command being called. So now I am going to make a key combination, second variables, which brings up the menu of all the distribution functions in statistics. And now I'm going to scroll down to option number 2 that says normal CDF. I'm going to click enter to select. And so now notice how we have seen back in our shaded area earlier, but this time we're having a definite low end. So in our case here it is 1.33, but for upper end we actually had, according to the picture we have seen, we had an indefinite upper end. So here I am going to give that as positive 1E99. So positive 1E99 for the upper end. That's to indicate we have an indefinite upper end. And again, we already found z-score, so everything we're working here is on the standard normal distribution bell curve. So that means I am going to default these two values at 0 for mu and 1 for sigma. So we're going to hit enter a few times. And again, just a quick reminder that users who are using a TI-83 or early TI-84 calculator, after you select the normal CDF command, instead of seeing a menu like what you have seen earlier on this software of mine, your command will be printed directly on screen. And so what you need to do is to actually type in the low end with a comma and the upper end with a comma, and keep the two values here defaulted at 0, 1. And now with the closing parentheses being given here, now we are ready for hitting enter. And so now the area shaded to the right hand side of z-score 1.33, or the area shaded to the right hand side of 1150 on our general normal distribution bell curve is calculated to be 0.091759 and a lot longer. So that means for our problem here, the area shaded here, our final answer is 0.0918, as I rounded to 4 decimal places. And as I said, and as you also have seen earlier, the answer which came out from our TI-83 or 84 calculator was a lot longer. But unless being specified otherwise, usually I would go with 4 decimal places rounding. And so this is our final answer. And in case the question is asking for the final answer to be expressed as a percentage, then this can be written as 9.18%. The same data with the description as given here, and we already had an empty bell curve with mean right at the middle 950 and standard deviation sigma equals 150. We are now asked to find the probability that on this general normal distribution we're having our random variable x taking values greater than 700 and at the same time less than 1000, or in other words, here we're looking at x being anywhere between this interval from 700 to 1000. And once again, watch out that sometimes we might have equal signs included here, but it won't change the way how we do the problem. And let's now go ahead and make a sketch. 700 is somewhere to the left hand side of 950. How far is good enough? That shouldn't matter. So 700, all it needs to make sense here is a being a value to the left hand side of 950. 1000, what makes sense is somewhere to the right hand side of 950. And it makes sense that the distance from 1000 to 950 should be shorter, should be looking shorter than the distance from 700 to 950. But here we have the upper limit of our interval, and here's the lower limit. So the probability where x takes value anywhere between 700 and 1000, this probability question is translated graphically as a shaded area between 700 and 1000. And here we're looking at two different values on our curve here. So be aware that each one of these will have a corresponding z-score. So I am now going to find each one of the z-score here individually. So z-score of my value 1000 on this bell curve is going to be done by the standard math of z-score 1000 minus 950 divided by 150. And it gives me, calculation comes out being a positive 0.33. The other value being 700, and now I'm about to find a z-score for 700. The calculation now, the formula comes out 700 minus 950 divided by 150, and that gives me negative 1.67 after calculation. And so once both z-scores are given, it's never a bad idea at all to label the z-score corresponding to each of these values on our bell curve. So 700 is equivalent or corresponding to z-score negative 1.67. 950 right in the middle is the center, so z-score is 0. And 0.33 is the z-score correspondingly for 1000. So this area on our currently general normal distribution would be the same. The area where x is between 700 and 1000. This area, once again, would be the same with the area on our standard normal distribution, where z-score is between negative 1.67 and 0.33. And at this point, we are ready to calculate the indicated area using the normal CDF command from our standard TI-83 or 84 calculator. And so we're going to get there by making a key combination, second variables, which now brings up the menu for all distribution functions in stats. And now I'm going to scroll down to option number 2 that says normal CDF and hit enter. And as a reminder, users for TI-83 or early TI-84 calculators won't see this menu, but instead you will see the actual command normal CDF being printed directly on your home screen, where you will need to enter your lower value and then your upper value, and with the value for mu and sigma. And now for this calculator that I'm currently using, which is the newer version of the TI-84, lower value we are going to enter negative 1.67. I'm going to hit enter, and we are going to enter 0.33 for upper value of the interval. And again, since these are already z-scores, that means we are working on the standard normal distribution bell curve. So I am going to default these two values at 0 for mu and 1 for sigma. So now let's hit enter a few more times. And now this should be how the command being completed after TI-83 and 84 users typed it in manually with your command right here. And now we are ready for hitting enter. And so now our answer here being 0.58184029 and a lot longer. This is the area on the standard normal distribution bell curve shaded between negative 1.67 and 0.33 for z-score. But this answer is also the same as the answer to the area, how big this area shaded between 750 and 1000 on our current bell curve here, on our current general normal distribution bell curve with center at 950 and sigma 150. So that now means we can have a final answer rounded to 4 decimal places. And now my final answer here appears to be 0.5818. And as you have already seen earlier, the actual calculation gave a lot longer decimal expansion. But unless being specified otherwise, I will normally round to 4 decimal places. And in case the question is asking for your final answer expressed as a percentage, we are going to write this as 58.18 as our final answer. 58.18%. The same data with description as given here. Now we are asked to find the probability where x is less than 550 or x is above 1200. And so now I am going to sketch the shading area that described our problem. And once again, our problem here is looking for the probability where x is less than 550. So what makes sense about 550, and the only thing it needs to make sense, is that 550 is somewhere to the left-hand side of 950. So now I am going to, according to the requirements, I'm looking for area shaded to the left of 550. Or it's indicating additionally we're including the probability for those x value that stays above 1200. So 1200 is a different value on our horizontal axis here for the x values, but stays somewhere to the right hand side of the mean. So 1200 is somewhere here, and the requirement says we want to look for additionally, aside from x less than 550, we additionally look for the x is greater than 1200. So there we produce a different area here, but disconnected from the other area. And so if you recall from those video lessons on the standard normal distribution that we have done earlier, then area is being broken up like this, and I tend to call them myself the disconnected areas. And anytime we're running with a problem where our area is being accumulation of disconnected areas like this, and the only fundamental, once again, to remind everybody, is that all we have to do is to find all individual pieces and total up. And now we are going to find z-score. This x value 550, we are now going to find its corresponding z-score. So I am using that subscript 550, indicating that the z-score we're about to find is specifically for 550. So on this bell curve where center or mean is at 950, then we're going with the value being 550, subtracting 950 and divided by the standard deviation, 150. Calculation comes out to be negative 2.67. And the z-score for the other value of x. Now I'm going to use the indication z-score with a subscript 1200, just simply to indicate that the z-score we're about to find is for 1200. The math here is 1200 minus 950 divided by 150. Calculation comes out to be 1.67. What it means once z-scores are calculated on these values is that 550 is at z-score negative 2.67 and 1200 is at z-score 1.67. Or in other words, on the standard normal distribution, then we are looking for the area shaded to the left of negative 2.67 and also the area shaded to the right hand side of 1.67. Remind yourself again, mean value right in the middle is at z-score 0. And now we can start finding all individual pieces of area. I am going to start out with the piece of area that is shaded to the left hand side of 550, or equivalent to the area shaded to the left hand side of z-score negative 2.67 on the standard normal distribution. And so now the area shaded to the left hand side of 550 on this bell curve is represented by the probability that x is less than 550. And of course, that area is equal to the area that z-score is less than negative 2.67 on the standard normal distribution. And so now we can start calling up the normal CDF command on our standard TI-83 or 84 calculator to get this area calculated. So now I'm going to go second variables and scroll down to option number 2 to call up my normal CDF command. So for this area shaded to the left hand side of z-score negative 2.67, it means we have an indefinite low end. So now I'm going to enter negative 1 E99 for the lower value of the interval. The upper interval of this area is going to be negative 2.67. And again, since we are using z-scores, so these two values are defaulted to 0 for mu and 1 for sigma. I am now going to hit enter a few times, and now we are ready for getting the answer. So this answer now means the area shaded to the left of z-score negative 2.67 on the standard normal distribution bell curve, or equivalently the area shaded to the left of x value 550 on the general normal distribution at center 950 and standard deviation 150 is 0.003796 and a lot longer. And for this problem, since this answer here as the area representing the area shaded to the left of 550 is not our final answer yet, I am going to keep the exact precision, the complete precision, so 0.003792 and a lot longer. Now let's advance to the other piece of area. That piece of area shaded to the right hand side of the x value 1200 on this bell curve, or equivalently the area shaded to the right hand side of z-score 1.67 on the standard normal distribution bell curve. As a symbolic question, it is the probability that we find a value that's greater than 1200 on this bell curve, or that is of course equal to the probability where z-score is greater than 1.67 on the standard normal distribution bell curve. And again, back on the calculator, now note that I am again going to store this value because that was our calculation value that we have had for the area shaded to the left of 550. So now I am going to store the complete precision of this value, getting it ready for adding work later on. So here I'm going to go store x and enter. So this command here tells the calculator to store the answer that we have obtained in our previous normal CDF command into the temporary x variable. And now I am ready to fire up the normal CDF command again to calculate the area to the right hand side of z-score 1.67. So now second variables, I'm going to scroll down to option number 2, and this time I am going to adjust my lower of the interval to 1.67, and that is how it came out from the picture that we have drawn. And so the picture of this problem is telling us that we have an indefinite upper end. So now I'm going to leave that as positive E99. And again, since these are all z-score values, we are going to keep these two defaulted at 0 for mu and 1 for sigma again. And I'm going to go ahead and skip a few lines, and now here we go. So now our normal CDF command is ready for doing the calculation. All right, so now this is the answer to the area shaded to the right hand side of z-score 1.67, or equivalently the area shaded to the right hand side of x value 1200 on our current bell curve, centering at 950 and standard deviation 150. So now I'm going to write down that answer: 0.0479, and a lot longer. So what we have found so far are all individual pieces of area, but neither one of these is the final answer yet. So again, recall that after we found all individual pieces, now we're going to need to add these two, or add all the individual pieces together. So now I'm going to add these two answers here. So that means my area to the left hand side of 550 here is going to be added to the area shaded to the right hand side of 1200. So now back on the calculator, I am going to, from where my current answer is, second answer, I am going to add with the value that we previously stored to the x variable. So now I'm going to hit x here and enter. So now this is really our final answer here, and this final answer, once I'm back on my writing board, this is the answer that is going to be rounded to 4 decimal places. So as of right now, it's very long in decimal, but as I said, unless being specified otherwise, my final answer is for these area problems are usually rounded to 4 decimal places. So now our final answer is 0.0513. And if the question is asking for a final answer to be expressed in decimal, then this answer here is the same as a 5.13%.